Welcome. I really welcome you. You are you are probably one of the beginning guests, beginners for the AjnaLens Tech Talk 4.0. And why we gave the name 4.0 is because we are reaching out to industry, smart industry 4.0, and all the ideas are, in and around to build a vibrant community for easy flow of ideas and opportunities also. So this is the beginning of those sessions. I think this is the second in line, and we'll be hoping to have more of such sessions. And so I welcome you, and let's start.
Yeah, thank you for your welcome. I'm excited to be here.
Great. So, Gaurav, just to give a brief introduction about you, we have worked together in the past, and I feel pleasure that today we are, talking today at this platform. You have been working for the past 6+ years in autonomous driverless field, and also in ADAS. So your primary fields of interest have been in and around AI, perception, robotics, and this is something which has been growing in the past decade and now is at a very, very advanced stage. A lot of companies are working in this, even in India. And I'm very happy to say that even in India the companies are working in this field. So in your own words, if you can share your early story, how did you find interest in this field or in these fields? That would be great.
Yeah, before I start on that, and I really am following your work as well, and excited to see you guys making demonstrations and interesting applications in India. And you were one of the good performers and one of the people who started a very interesting project at High Tech Robotic Systems where we work together as well. So
Yes.
I'm excited to be in touch with you again and discuss ideas here. So, in terms of my early story, you know, when I was doing my engineering, I was always sort of interested in computer science and interested in sort of the AI aspect of computer science as well. So one of my, the project that I did at the end of my bachelor's was involving, grading Hindi essays. And that was a rudimentary AI technique called latent semantic analysis
Right.
that I worked on. So sort of, reducing the large sort of representation into a smaller one and doing some similarity matching between them. A simple cosine similarity matching and so on.
Hmm.
So that was where I sort of got hooked to AI. But the work that I picked up next was also interesting, and sort of brings me to an interesting point that sometimes it's important to understand the basics. And if you look at computer vision, like sensors and software is sort of the basics here. And then you go on to some certain other basics that are on the geometry side and the feature representation and so on. So I was working a lot in driver technology. So that was more low-level firmware software, kernel drivers, and my sort of exposure to cameras was on the kernel layer, writing drivers for different kind of cameras. Also doing things like audio-visual synchronization and so on. But how I sort of moved into the side of robotics was looking at the DARPA Grand Challenge in 2005. So I read about it actually later in the day, around 2011 or so, when I'd been working for a few years as a kernel engineer. Um, I heard about this DARPA Grand Challenge and I was like mind blown by how they were driving cars in deserts just using LiDAR sensors and camera sensors, and able to sort of create a two-dimensional map of the area around them and sort of navigating through that. So basically, it's a very simple sort of 2D map. Think of a bird's eye view. Here is an obstacle. Here is a drivable area. You go to the drivable area. That was sort of the application that they were doing. And I was really excited to see that, and I decided to apply for robotics at Carnegie Mellon, and that's what sort of got me hooked into computer vision and this side of things. So yeah, just a brief introduction. to how I got into computer
Very
vision.
interesting. Very interesting. Can you tell us about your current work and your recent, even in your previous companies, your work in autonomous driving and in perception. So your work in R&D for the same. So,
Yeah.
yeah,
Mhm. Yeah, and so when I went to do my robotics course, one of the areas I was really interested in was computer vision, and I got the opportunity to work with Marshall and Drew Bagnell, who are two great professors at Carnegie Mellon, and they were working sort of to do monocular depth perception. This is the sort of classical or holy grail problem actually these days that we're solving. It's still not solved,
correct.
right? So how do you how do
We
you
are,
get
that is one of the challenges even we are facing.
Yes, exactly. So I can say I was doing that in 2012. So that's when I was, starting off on my journey of computer vision. But it was really interesting because I dropped into the hardest problem in CV, with at that time having no background in actual CV. So which was very like throwing me into the deep end basically,
Right.
and have to sort of swim in that. So I had to sort of teach myself and do the courses on fundamentals, sort of understanding geometry, image geometry, which I would still say is like one of the most important basics of computer vision that anybody
I
should understand,
agree.
along with the sensors. Yeah. So I know you've been also been very very conversant with that, and sort of understand that's an important side. So that was sort of where it started, and I've done a lot of the camera calibration work and so on as well. So I think that was a good grounding in that side. But I would say, like when you talk about ADAS and AV, which is something I did later on, um, I think recently what we've been focusing on is the same, like monocular depth perception. And why? Because there are a lot of dash cams that are out there. If you see what's happening now, there's a plethora of cameras that are out there on fleets. So Ridecell works with a lot of car fleets, which includes truck fleets, which includes the Amazon fleet here in the US and other. And they're sort of targeting these kind of different fleets. I wouldn't say Ridecell works with all of these, but they're targeting different kinds of fleets. Now, with these fleets, you have a lot of dash cams that are giving you information. Now, how to make sense of that information is where computer vision comes in. Um, that's one aspect that we are currently looking at,
Mhm.
and hence monocular camera depth perception and detection
Mhm.
is a current challenge that we are heavily working on. So in in the field of AV, that is also something that's important because the price of the sensors has to be kept down to a minimum.
Correct.
And using lidars it makes the problem easier, but when you have a production car and you have just lidar on it, the cost is going to go up pretty high.
Great.
Lidar has its disadvantages. So
Right.
that's where sort of my research has always focused on camera, because that's the sensor that can definitely bring computer vision, or can bring AI to these vehicles much faster in a more scalable way.
Correct. And I think that is basically, one of the major points between academic research and commercial research. Because if it were an academic project, you would have like almost in a good university or a good institute, you would have limitless resources almost to make one car up, success. But when it comes to production ready, you would have to, in your research, bring down the costs of all the sensors, and therein where cameras play a role, and lidars might not be that economical. So
Absolutely, yeah, absolutely. And sort of the whole of system approach is what
exactly.
makes things different in academic research versus a business side. And I would encourage everyone to think about that when they're thinking of like the
Hmm.
problem they're trying to solve in industry. So you can't just choose any kind of camera. You have to think about many factors, like what's the resolution, Do I need to send this data to some other location? What's the compute that I have on board? What's the compute that I'm going to use maybe off board? What sort of cloud computing am I going to use resources over there? What kind of connection can I expect between the cloud and the on-edge device and so on? So there are various factors that come into this. The price of the sensors, the kind of does it support HDR or not? Does it
Mhm.
support LED flicker mitigation or not? So if you're doing something like traffic light detection, and if you don't have LED flicker mitigation,
Correct.
you won't be able to detect the traffic lights correctly. So
True.
those kind of features and sensors and system you need to think about before you get to the interesting part, which is the CV AI
Correct.
algorithms, which people
Correct.
usually focus on that first.
Yeah.
And that's fine, but also need to have an understanding of the hardware and the system.
Correct. I agree completely. So having a bird's eye view of the actual problem that you're trying to solve. So planning it out before and then getting into the nitty gritties of implementation. Very valid point. Another question, which is very interesting, I think, to me and to many of our fellow colleagues in CV and AI. So you being the expert in this, so you have been working in the field of advanced driver assistance systems and driverless autonomous vehicles for so many years now. So what do you think are the major technologies that have been brought to mainstream adoption in various industries because of advancements made in ADAS and autonomous driving?
Yeah, that's a really great question, and ADAS is the now. If you look at AV or autonomous driving, that's the future. We
Yeah,
still haven't reached a stage that's being adopted. But if you look at ADAS, increasingly that's getting adopted,
correct.
even in countries like India. And that's what the experience in high tech also taught me a lot. Um, so we definitely, and Yukti, you know this well. You worked on the camera Novus Aware,
Yeah.
which is proudly now in fleets in India. So
Yes.
you've been a big part of that, and that's definitely something that you see not just in India but in a lot of developing countries, also in Europe and beyond. Humans are actually very good drivers when they're paying attention. Um, so a system that just assists them to sort of know if they're falling drowsy or feeling drowsy or not attentive enough, itself saves a lot of lives. So having that kind of sensor that's just looking at the human, kind of checking him, that's one thing that's being adopted a lot
Mhm.
all over the world. And one of the other aspects is also the outward looking camera. um, so they found out that a lot of these collisions are happening, because the car in front suddenly brakes and the human is sort of looking at the road, but he's sort of going along at a good speed. And that happens a lot in places in the West, especially with big roads. And you have a collision, a forward collision. Basically, your forward part of your car hits is the back part of the car. So a back part of the car in front of you. Again, pretty simple computer vision techniques to detect the back of cars. Use that and the geometry. So you have some calibration information about the camera. You have the intrinsics of the camera and the height of the camera, and you're doing some visual odometry to get sort of the pitch of the camera as well as it moving out through the scene. Using that information, you can sort of create a picture of where objects are laterally and longitudinally from you, and then use that to calculate time to contact, which is basically the time in which you're going to have a collision with the vehicle in front. And that sort of technology is coming into vogue a lot. Again, it's Mobileye is one of the big players,
Yeah.
and if you look at all the OEMs across the world, um, and you look at Tesla, for example, that's one of the biggest examples here,
Yeah.
that's been widely adopted.
Yeah.
So Tesla is basically an ADAS system right now. It's
Yeah.
not, even though Elon Musk likes to say that it's a L4 system. I would love to, say that it is an L4 system, but unfortunately, I have to differ with him. It's still the production version of Tesla is still a L2 ADAS system. It
Correct.
helps you sort of keep lanes and not collide with something in front, and that's it. So that sort of system is coming into vogue, and not only Tesla but other OEMs are bringing out such systems. And you see BMW, you see Mercedes, you see Toyota, you see a lot of these companies investing a lot of research in this. um, And not only these OEMs, but also tier ones and tier twos who are sort of supporting this aspect as well.
Right.
So that's one area that's sort of being adopted more and more. And you think of it in terms of collaboration between humans and AI. Um, because in an ADAS system, you're not giving AI the full control, right? You are sort of driving the vehicle yourself, and the AI is sort of being an advisor to you,
Mhm.
telling you, hey, you're going wrong here or you're going wrong there. So
Mhm.
it brings us different set of problems
Mhm.
to autonomous driving, because autonomous driving, you need to be perfect all the time because you're actually driving the car, versus when you're doing an ADAS, like an advisory system, you have certain leeway there, and sometimes you actually want that leeway. It's actually desirable,
Mhm.
because if you're too perfect, the human might actually stop paying attention,
Correct.
which sometimes happens in Tesla cars.
Correct.
It's a very good ADAS system, and that's actually sometimes a negative.
Right, I agree. So there are 2 points that I got from your, answer right now. One is different technologies that have now in a very advanced stage because of developments in ADAS and AV, like perception, monocular depth estimation, even like SLAM. Now, SLAM has been there for quite a few years, but that has become like in mainstream and taken into different domains because of advancements and interest in ADAS and AV. And now SLAM is being used even in augmented reality. It is like the heart and soul of augmented reality, mixed reality. So even in different industries and applications, the advancements in perceptions of mapping, of localization, of relocalization, and things like that. All of these are so important to so many industries now. So it is the technology just going cross industry, and is very important. And the second point that I got was human AI collaboration. What is the right judgment? Where do we give the full control to AI, and where do we have it as a collaboration between human and AI? And as you rightly said, Tesla is work is so safe and is successful because there is an element of human AI collaboration. The judgment is still held in the human's hand, and AI is the advisory. So great point there. I agree. It's so coming to human AI collaboration, which I think we should really discuss further, is what is your opinion on human AI collaboration? People are, the skeptics on AI keep on saying, AI will replace humans and will take up too many jobs, and whether it will be a boon or evil, we wouldn't know. So, human AI collaboration, what is your take on that?
Yeah, that's interesting, and you're right. Like, and we hear it all the time when we say we are AI researchers to anybody in our families or friends. As the first question they ask, hey, are you guys going to sort of take over the world? And like they think about different movies and Hollywood, and now even Bollywood, sort of showing that. It's sort of the cliche there, right? But
Correct.
I think we as researchers think of AI as a tool, right? Uh, and humans are always sort of working with AI. Whenever we're doing anything, we are generating data, which
Mhm.
on the background, by the way, is being read by an AI engine, which is like learning from it. Sometimes there is supervision, sometimes there is not supervision. So we're always collaborating with AI, or to make an AI system work better, you need human data. You need
Correct.
humans generating that data, and that's where I see the first level of collaboration. So there are many levels of collaboration in my mind. The first level is on the teaching side itself, like what is the AI supposed to learn, what is the domain knowledge, and that's something that's given by the human. Um, so that's one side of human AI collaboration that we see. And the second side is, of course, what we bring as AI researchers, which is sort of training or understanding which networks, which architectures, how to sort of structure the AI system so
Mhm.
that it works.
Mhm.
And I would like to also point out that what helps, even in things like autonomous driving, is if you are a driver who drives a lot and sort of understands what driving is all about, you can understand how an AI system can be structured. That gives you some domain knowledge about how an AI system can be structured. But keep in mind one thing, that we humans have certain sort of fuzziness that we create in the world, and how we show that in an AI system is very difficult to replicate. Um, so that's one aspect, and sometimes how humans think about things, machines think very differently about things. So domain knowledge can be a boon, or sometimes can also be a bane.
Mhm.
Depends on the and sort of application that we have for the AI system. So I'll give you an example. Like, we find when we do autonomous driving here in the US as well,
Mhm.
the biggest sort of interesting insights that we get are from actual drivers. Like what kind of thresholds to set for different aspects. What have they seen on the road? What is the weirdest thing that they've seen on the road? And those kind of insights come from experience, and that's where humans can actually teach AI using that experience, that wealth of experience that we've gathered. Because the world that we live in and the world that we're creating AI for is human centered. And we need to understand how humans navigate through that world, and
Correct.
then try to make AI actually help in the human navigation and the human work inside that particular world.
Great. I agree. So basically, it's the same even in our industry. I think if AI is lacking at all, that is wholly and solely because our lack of understanding of human nature, of human knowledge, how human mind actually works. Because if we understand that, then only we can train an AI. So I think with the advancement of
Yeah.
AI, we are actually also exploring our own minds better. Behavioral studies are at their level best because of advancements in AI. So I agree. So and
Absolutely, yeah. And that's a great point, you talked about, and it actually brings us back to, even if you look at it from an Indian point of view, it brings you back to sort of Buddhism and Hinduism, talking about
exactly,
everything is in your mind, right? So how you represent the world is in your mind. How do you sort of feel about the world? What you see, what you hear, what you feel.
mhm,
These are all sensors that are telling you different things, and you're creating a representation inside your mind. You can
exactly,
train your mind, and similarly you're training an AI system which has different kinds of sensors, which have different good things and bad things to them, and that is being used to sort of train a system. So I see the parallels that you were saying, and it's really interesting to think of it in that way. Yeah.
right. In fact, not forcing branding my own company, but the term Ajna actually is a third eye,
Hmm.
Agya, the Sanskrit word. And the idea for our, selection of the name AjnaLens was giving another sensory, another kind of perception to humans, because humans can reach to that level. But if you are unable to reach to that level for an average human, what could you give? What tool can you give for them to take their sensors to next level, to so that they can be more intuitive and do their jobs better? So that was the inspiration vision of our company as well. So great linking to that aspect when we talk about human AI collaboration. Talking about now that we have talked about human AI collaboration, different aspects, how it is implemented. According to many research reports on AI and business strategy, we find that companies that are able to leverage human machine collaboration are actually best positioned for success. But not many companies are actually implementing or are able to implement that yet. So unless it's a direct application and going into the product, how human machine collaboration and business strategy for companies, what would be your view on that?
Yeah, it's a interesting question, and I think one aspect is that it's very easy to sometimes throw people at the problem, especially in India. So if you think about anything like mobile robots, you'll find it's easy to say, "Hey, I can just replace them with certain number of people with certain machines, and they can do the job." Um, I think, but the aspect here is, if you want to think about improving the quality of life for everyone, a lot of people are doing things that are pretty mundane, and this can be done better using a sort of an AI system
Mm-hmm.
that are there. Even something as simple as teleoperation, can help, and it definitely helps in sort of dangerous situations as well.
Correct.
So if you have any situation where robots have to go into some kind of nuclear fallout area, which happened when the reactors had an accident in Fukushima.
Yeah.
That's where you see sort of even teleoperation robots sort of going along, and they have some basic AI systems that are there as well. So I think in terms of adoption, I feel that the Hollywood representation of AI is sort of hampering a common man's perception of AI. Um,
Correct.
AI is not an artificial general intelligence yet. It's not something that's like a robot that will talk to you yet. There's research happening in that area, but artificial general intelligence is pretty far away. Um, there are many low-hanging fruits on the way to this, where there is a lot of collaboration that might be required, because the AI will not be able to do everything that's possible, but will be able to take away some of the mundane aspects of the job, and abstract that out from the human, or take that away from the human, and let the human sort of focus on controlling maybe a number of robots, or a number of sort of situations, and take high level decisions, leaving sort of lower level decisions to the AI system.
Mm-hmm.
So that's where I feel like the understanding of what AI is maybe lacking, and sometimes people are already using AI, but they don't actually realize it, that they're using it, and that's sort of one aspect that's there. But if you look at sort of the high or the higher implementations and how that goes into business, um, I think companies are slowly realizing. I see a lot of interesting applications, in the US and now in India as well. Fraud detection, of course, has been a classic one. Sort of
Mm-hmm.
understanding checks and sort of image processing on checks, speech
Mm-hmm.
recognition, and understanding what people are saying. So each time I call some call center now, I don't talk to a person in India, but I actually talk to an AI bot, who's able to understand basic things, to at least sort of push me in the right direction, and then I can go to the right department. So all that is coming along, at a pace. As AI researchers, we would love to quicken that pace, and there is some aspect of some people not being happy with that. So some people will just, whenever they hear a bot, will be like, I just want to speak to a human, right? And they just want to get away from that and speak to a human. So the human touch, therefore, will always be important in many cases. And I'll give you a very concrete example of a sort of adoption of autonomous vehicles as well.
Right.
There is a huge gap in sort of the public accepting autonomous vehicles. Tesla, okay, does give you some kind of solution, but still allows, or still tells the human to sort of take control. And the human is sort of at fault if something happens. It's not the AI system, right? Um, what we actually did at Ridecell was we said that we'll drive the car when there is no human in the car.
Mm-hmm.
So what we'll do is, at night, if vehicles in the fleet are sort of distributed all across the city,
Mm-hmm.
we'll sort of have a heat map of where the usage is during the morning, and
Mm-hmm.
drive the car at night using certain routes that are well known, and bring the car to those places where in the morning they'll be more likely to be picked up. So this is sort of managing a shared car fleet,
Mm-hmm.
and sort of keeping that human element, that the human might have certain expectations of the AI out, by actually doing some job that is more mundane, that takes away. So how would you do it generally? Is you will send people out late at night to go and pick up those cars and drive it. That's not good for their health. It's not good in general, and there's a lot of money wasted in transporting those people to different places as well. So instead, if you have the capability in the car to actually come back to certain locations, and drive conservatively, because at night the traffic is usually less, you're able to sort of get away with more things,
Mm-hmm.
and get back to sort of positions. So I think those kind of innovative solutions is where companies need to think about how AI can be adopted, and sometimes there are those moonshot ideas that okay, we're going to sort of make a full blown autonomous car, but it takes time to get to those, and there are a lot of low hanging fruits on the way that a lot of
Correct.
companies are looking at. Yeah.
Correct. Very interesting thoughts. And I think the main takeaway would be no fear of AI. Nobody has to fear AI, all those Hollywood ideas, because AI is and will take over the mundane part of the jobs, and we will have to upgrade ourselves as humans, and we will be getting more interesting tasks which we will have to do, so that there will be evolution in the jobs, as there will be evolution in AI. So there
Yeah,
is nothing to fear.
yeah, absolutely, and I think um, there is one aspect where AI is not scary, but has an aspect where we're not sure what will happen. Like where is it going to fall? Like where is the cookie going to fall? Left,
Right.
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 That's the singularity time, the artificial general intelligence time. When AI sort of has a consciousness of its own, just like how we say, we as a human have a representation of the world and we have a consciousness. It starts thinking for its own,
Mm.
from its own side. It's not sort of programmed to do only one thing, but it can do multiple things,
Mhm.
and sort of can make those decisions as well. I think that's the level at which I would still say we need some more understanding and research, to understand what will happen at that point, and that might be a dangerous point. But if you think about some ideas there, and that's where human AI collaboration comes in. If a human can somehow be interfaced with an AI system. So
Mhm.
now what happens is, like, when I read something or when I talk to you, there is a certain speed at which I can process information, right? The speed at which I'm talking, the speed at which I can read. But a computer system can do this much faster because it has like a LAN connection or a Wi-Fi connection, and is talking to the hard disk and so on. It's like much faster data understanding. Um, Over there, if and this brings me to Elon Musk's other interesting work, which is the Neuralink idea. So that's another sort of human AI collaboration taken to another level, where you have a computer interfacing with a human directly, physically, and you're able to sort of transfer information directly from the computer onto the human's brain and inside his nerve cells directly, and sort of make him a superhuman in that way. So he think about the Matrix as well. Like, they could learn how to fly a helicopter in seconds, right? It's something like that. You sort of get that information downloaded into your system, and that's where, I believe that people who are working on this cutting edge of research, they understand this, and they know that we need to merge with the machine. Otherwise, there might be a point where the machine consciousness comes in, and there is a danger that humans will get left behind. They will be sort of the losers of evolution, while machines would be the winners, and the next form of evolution that we help create ourselves, but takes over from us. So having that sort of collaboration in that direct physical way might be an interesting thing to see in the future. Yeah, I don't
Really
know if you'll be alive to
fascinating.
see that, but let's see.
The way things are happening, I'm sure we will be.
Yeah,
Really
no doubt.
fascinating. We are living in the interesting times.
Absolutely. Yeah.
So I think the very last question that I would come to is, for our young AI developers, what advice would you give them to prepare them for commercial R&D? Considering that AI landscapes are so volatile and keep changing so rapidly, so what is your advice to them?
Yeah, I think one of the aspects is, we talked about earlier, is sort of the basics, understanding some basics. But I'd like to also point towards domain knowledge. So whenever you get into a particular field, it's good to sort of understand that field, understand what are the requirements of the users, understand where are the opportunities to build certain things that are there. So understanding the user's pain point and looking at it from a product perspective is going to be interesting for the developer side. Um, in terms of looking at technology and how it changes, you're right. Like every new year, we have great advances. We have sort of the compute system also changing, is helping in a lot of these things, right? So
Yeah.
neural network was dormant till you had GPUs come into the scene. Now you have TPUs, and you have even other kind of spiking neural networks coming up, and the hardware that supports that. So there is a lot of shift happening in the industry. So what I would suggest is now is a really a good time to invest in your own knowledge and your awareness, to think about what is happening in your domain, to always question and talk to people in your domain. And this podcast or this sort of discussion being one of those things, you sort of get a lot from the exchange of ideas, and reading a lot of papers and ideas that people have out there. The more papers you read, the more you can apply ideas to your research. You can see what worked for other people, and not directly maybe use some things, but use those same ideas in your own research. So I would say, like, reading papers and getting ideas from them is a really great thing to do. Attending different conferences. So invest in yourself, and be in a company that also does that as well. If I have to choose a company, I would look at a company that actually invests in its people by understanding that AI people need to be updated all the time, need to be part of these conferences, need to be encouraged to be part of conferences, publications, and so on. So that's one thing that you should do for your career. Um, Getting the basics right, as I mentioned, like understanding the sensors that you're working with. If you're in vision, you need to understand the cameras. If you're in lidar perception, you need to understand what a lidar does, and so on. These aspects are important. But one of the a mundane aspect that sometimes gets left out is benchmarks and testing. And you know that very well, Yukti, as well.
Yeah.
The product really goes to the next level, and towards user acceptance once we have a benchmark set, and then we are sort of aiming for the benchmarks. We have a data set, we have a benchmark. We are all sort of it focuses your efforts. So the faster we think about benchmarks, data sets that you have to use, and the faster your development will go in that particular direction. Um, Also, always look at your data as an AI engineer. Understand your data. That is key before jumping straight into algorithms. Um,
Mhm.
Look at your data. There are a lot of things to learn from your data, and your system is as powerful as your data. If there are issues in your data, your system is not going to perform well. So those two aspects I would like to point out. And always thinking about how to scale your product, how to take those things forward, makes you a more accomplished engineer. It separates the engineers who just do what they're told versus engineers who think further ahead, and are assets to their managers and their teams. So thinking about scaling, thinking about how this product is going to look in the future, how we're going to improve it, having that sort of continuous improvement mindset is something I'll also give an advice for.
Amazing, amazing, and very insightful indeed. And I hope our young, the freshers or who are still in college and aim to be AI developers, or who have just started out, I really hope they listen to this and really put in efforts for this, because I feel people are just jumping the bandwagon, taking the trendy algorithms, just applying, open source codes to some open source data, and then thinking that this would be enough, without really getting into the nitty gritties of when to choose what,
Mhm.
basically what algorithm to choose at what point of time for what problem. And that is really important for commercial R&D. Maybe not so much for academic R&D, where you just want 99.99% accuracy. So all these aspects are really important. I think this brings us to the end of the talk. Any more ideas that you would want to share as closing remarks?
Yeah, I think one aspect I would like to share is, when you talk about engineers and sort of they jumping on bandwagons and doing that, it is something that people do sometimes when they're young, and they don't understand what they're doing. So don't be too hard on yourself as well. Sometimes is what I would say to people. Even if you make a mistake, you should sort of realize and correct it, sort of going forward. But one aspect is sort of listening and talking to people who have been there, done that. Always sort of gives you an insight into what goes into building a product, sort of understanding that very deeply thinking about a product is something that people should definitely incorporate, and having sort of also a good breadth of ideas and experience in the world is something I would also say people should think about. So I feel definitely I benefited from having a system background, and then coming into AI. I could think more about sort of sensors and these things as well.
Mhm.
So sometimes you never know what you did before will help you in sort of understanding these things. So don't, I see this sometimes as well, that people are like, oh, I will only study AI and I will not study anything else. Like if you don't study software engineering, if you don't study systems, hardware, you don't understand those aspects, you'll be an incomplete engineer. You
Correct.
will in a company, you will be very typecast into a very specific set of problems, and you never be able to sort of rise beyond that and sort of understand things from
Mhm.
a much broader perspective. So I would say that have a good breadth of knowledge, and that will really help you going forward.
Exactly, especially for innovative teams and startups specifically, we really want people to have a wide, array of skills rather than
Yeah,
having a very
absolutely.
niche idea about what they do and what they can do. So having an open mind can be the first step.
Yeah, right,
So
absolutely.
great, Gaurav. It was very, very, very interesting conversation. Even on a personal note, it was very interesting and insightful.
Yeah,
And
yeah.
I hope to, have many more conversations with you on different topics. And thank you on the behalf of AjnaLens team. And here we were in talks with Gaurav Singh, system architect at Ridecell, USA, right now. And all the very best to you. And
Thank you, and to you too, and to all your viewers.
thank you so much.